Hi everyone, today we will see a problem from alternating current. So the question goes as an LCR circuit with a 100 ohm resistance is connected to an AC source of 200 volt and an angular frequency of 300 radians per second. When only the capacitance is removed, the current lags behind the voltage by 60 degree, and when only the inductance is removed, the current leads the voltage by 60 degree. Now calculate the current and the power dissipated in the LCR circuit. So in the first case, the capacitor is removed. So the capacitor is removed in the first case, and when the capacitor is removed, this becomes an LR circuit. So we know that in an LR circuit, here is XL and here is R, and the resultant is like this, and it's given in the question that the current lags behind the voltage by 60 degree. That is nothing but the phase difference. So this is the 60 degree, and now we know that this is also XL, so that will be tan 60 degree is equal to XL by R, and we also know that tan 60 degree is root 3, so root 3 is equal to XL by R. So now we can find that XL is equal to root 3R. So from the first case we have found out that XL is equal to root 3R. So in the second case, inductor is removed, and when the inductor is removed, this becomes an RC circuit. So we know that in an RC circuit, here is R and the XC is in the downward direction, and the resultant is like this, and it is also given that the current leads the voltage by 60 degree, and that's the phase difference. So this is the 60 degree, and this is XC, and this is R. So here also tan 60 degree is equal to XC by R, and which implies that XC is equal to tan 60 degree is root 3, so XC is equal to root 3R. So XL is also root 3R and XC is also root 3. So XL is equal to XC. This is the condition of resonance. So now we have to find the current and the power in the resonance condition. So we know that at resonance the total impedance is equal to the resistor of the circuit, because this XL and XC would get cancelled when calculating impedance. So there will be only resistance. So the impedance will be equal to resistance. So now we have to find the current. So current is nothing but V by Z, and V by Z is nothing but R. So V by R. So here is 200 volt, that is the supply voltage, and so 200 divided by R is nothing but 100. So I is equal to 2 ampere is the current, and this is IRMS. We always know that in an AC circuit we always find RMS value of voltage and current. So this is IRMS, and this is also VRMS. Now we have to find the power. Power is equal to IRMS into VRMS by power into power factor cos phi, and we know that cos phi is equal to R by Z, and at resonance the impedance Z is nothing but R, so cos phi is equal to 1. So the power factor is 1, so this becomes IRMS into VRMS. IRMS is 2 ampere, and IRMS is IRMS is 2 ampere, and VRMS given the question is 200 volt. So 2 into IRMS into VRMS 200. So 2 into 200 is nothing but 400 watts. 400 watts. So power is 400 watts. So this is the answer. Take my hands now. You are the